Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. Carolina Bays Time of Emplacement. This video examines the various times that have been proposed for the origin of the Carolina Bays. The determination of the correct time of emplacement can be approached by identifying the conditions in the Earth's temperature record that would have met the requirements for the creation of the bays. One of the requirements is the occurrence of a glacier ice layer covering the convergence point of the Nebraska rainwater basins and the Carolina Bays by the Great Lakes. It can be easily shown that well-preserved Carolina Bays and Nebraska rainwater basins are perfect ellipses. The fact that ellipses are conic sections implies that these geological features originated as inclined conical cavities. The width-to-length ratios of the ellipses can be used to calculate the inclination of the original conical cavities. The glacier ice impact hypothesis proposes that an extraterrestrial impact on the Laurentide ice sheet during the Ice Age ejected ice boulders and that the secondary impacts of these ice boulders created the inclined conical cavities that produced the elliptical features in Nebraska and the East Coast. Although many geologists have proposed that the Carolina Bays were made by wind and water mechanisms, the main features of the bays cannot be explained by gradualistic terrestrial processes. Well-preserved Carolina Bays have precise elliptical geometry, and the bays can overlap while keeping their elliptical geometry. The bays have raised rims, which is a characteristic of impacts because impact cratering displaces material laterally by horizontal compressive forces and ejects debris ballistically to produce stratigraphically uplifted rims. The major axes of the Carolina Bays and Nebraska rainwater basins converge by the Great Lakes, which is another feature that can only be explained by impacts. It is also important that experimental modeling is able to produce inclined conical cavities that appear elliptical and have the characteristics of the Carolina Bays. The time of emplacement of the bays needs to satisfy four conditions. There has to be an extraterrestrial impact on the ice sheet that covered the Great Lakes. Currently, there is evidence of a platinum anomaly 12,900 years ago, although the location of the impact or airburst has not been ascertained. The convergence point of the bays has to have been covered by an ice sheet. This can only happen during glaciation times. The time of emplacement must be associated with an extinction event. This is due to the fact that the impacts that made the bays had energy of many megatons, and the saturation bombardment would have killed fauna from the Rocky Mountains to the east coast of the United States. The bays are fragile sandy structures that are easily eroded, so they must have formed relatively recently in order to still exist today. We can use a chart of the Earth's temperature during the last million years to identify the time intervals during which it would have been possible to meet the four conditions for the formation of the Carolina Bays. The Wisconsin glaciation extended from approximately 75,000 to 11,000 years ago, and there were several times when ice advanced to cover the Great Lakes. The Younger Dryas was a cold period at the end of the Wisconsin glaciation starting 12,900 years ago that lasted 1,300 years. The maximum ice extent occurred approximately 25,000 to 21,000 years ago during the last glacial maximum. The Eemian interglacial occurred from about 130,000 to 115,000 years ago. The Eemian was preceded by the Illinoisan stage, which lasted from 191,000 to 130,000 years ago. During the Illinoisan stage, the Laurentide ice sheet covered about 85% of Illinois. The saturation bombardment that created the Carolina Bays would have killed all animals under the ejecta curtain of the extraterrestrial impact. Most of the bays shown here were made by impacts with energy of several megatons. This graph shows the extinctions during the last 56,000 years. Many animals went extinct at the Younger Dryas boundary 12,900 years ago. There are other extinctions in this 56,000 year time interval, but the most severe extinction is at the onset of the Younger Dryas. Many of the proposed dates for the origin of the Nebraska rainwater basins and the Carolina Bays come from radiocarbon dates and optically stimulated luminescence. Although the dates may not reflect the time of formation of the bays, they correspond to the date of the terrain, and this can provide general guidance about the time of emplacement. The radiocarbon dates for the Nebraska rainwater basins range from 21,000 to 26,000 years ago, which puts their time of formation during the last glacial maximum of the Wisconsin glaciation. A study of the Carolina Bays using optically stimulated luminescence produced dates ranging from 2.2 to 74.3 thousand years ago. Except for one recent date, all these dates are within the range of the Wisconsin glaciation. The dates provide a rough estimate of the geological time when the bays were emplaced. Michael Davias and Tim Harris proposed that approximately 786,000 years ago, a tangential extraterrestrial impact in Michigan heated material to a molten state and expelled it vertically at near escape velocity. The material formed tektites that transited outside the atmosphere and re-entered at great velocity to form the Australasian tektite field. The extraterrestrial impact also ejected a slurry of water and sand that was deposited across a pair of butterfly arcs extending out from each side of the impact. The ejected sheet exhibits a surface texture of popped bubble depressions which have evolved into today's Carolina Bays and Nebraska rainwater basins. The lack of an identifiable impact structure may be explained by the scouring action of 7 full glacial ages, which could have produced the current-day Saginaw Bay Basin. Looking back at our reference chart, we see that 786,000 years ago, the Earth was in an interglacial period. This is not important for the Davias-Harris hypothesis because they propose that bubbles in a slurry of water and sand made the bays rather than impacts by ice boulders. It is important to note that the Yellowstone caldera erupted 630,000 years ago. This sequence of events means that if the Davias-Harris hypothesis is true, the Nebraska rainwater basins should have been overlaid by the Lava Creek ash bed from the Yellowstone eruption 630,000 years ago. This layer of volcanic ash is not mentioned in the paper by Kusila referenced earlier. Chris Cottrell has a YouTube channel called Dabbler's Den that discusses the Carolina Bays. Please check it out. Some of the videos discuss the Atlantic shorelines and how they place constraints on the dates of emplacement of the Carolina Bays. Chris examines some of the previous shorelines of the Atlantic coastal plain studied by Professor Donald Thiem, and he tries to deduce the time of emplacement of the Carolina Bays based on the geologic terraces where the bays are found. We will be paying particular attention to the Pamlico Terrace, which is 7 meters above sea level and has an estimated age of 100,000 to 500,000 years. We will also look at the Princess Anne Terrace, which is 4 meters above sea level and formed approximately 40,000 to 80,000 years ago. The table of relisted shorelines lists the ancient shorelines that have survived to our present time, but it does not include the Ice Age shorelines that have disappeared due to sea level rise. During the last glacial maximum, between 26,000 and 20,000 years ago, the sea level was 120 meters lower than today, and Myrtle Beach was 105 kilometers away from the coastline of the Atlantic Ocean. This image shows the eastern part of North Carolina near the Virginia border. The lack of bays at the lower elevation implies that the Carolina Bays were destroyed when the sea level was higher, around 80,000 years ago. The Pamlico Terrace at an elevation of 7 meters above sea level has many Carolina bays, but the Princess Anne Terrace at 4 meters above sea level does not have any bays at all. The logical conclusion seems to be that at one time all the surface in this image was covered with Carolina bays prior to 100,000 years ago. But when the sea level increased and covered the Princess Anne Terrace 40 to 80,000 years ago, all the bays in this terrace were eroded. This could indicate that the Carolina Bays are more than 100,000 years old, and therefore they cannot be associated with the Younger Dryas impact 12,900 years ago. The conclusion seems obvious, but nothing about the Carolina Bays is so simple. The National Hurricane Center says that when a storm surge coincides with a normal high tide, the resulting storm tide can be 20 feet or higher. The Princess Anne Terrace at 4 meters of elevation can be flooded easily by the storms that frequently batter the Atlantic coast. The temporary rise in sea level due to storms and high tides is sufficient to erase all traces of Carolina Bays in low-lying areas over a period of time. A 15-foot storm surge would inundate the Princess Anne Terrace with half a meter of seawater, and a 20-foot storm tide would cover the Princess Anne Terrace with 2 meters of seawater. This is deep enough to stir up some sand and erase all traces of the Carolina Bays. In addition to storm surges and astronomical tides, heavy rainfall can erode the Carolina Bays. Hurricane Florence was a powerful and long-lived hurricane that caused catastrophic damage in the Carolinas in September 2018. Torrential rain flooded the landscape. This image shows a farm field with a multitude of water plumes dragging sand toward lower elevation. The flow of water on the surface can completely obliterate the sandy structures of the Carolina Bays. Rain can erase all evidence of the Carolina Bays relatively fast. The upper image was taken in 1930 and shows some well-defined Carolina Bays in the middle of the picture. In the bottom picture, many of those bays are completely gone after 90 years. We cannot blame the disappearance of these bays on farming or other human activities. This is an image of the Lewis Ocean Bay Heritage Reserve, which has been kept in relatively pristine condition all this time. Nevertheless, the Carolina Bays are disappearing rapidly without encroachment by the ocean. This is what rain can do to the Carolina Bays. This is another example of 78 years of erosion. Little by little, the features of the bays are washed away by rain until the bays finally disappear. A review by Melton in 1956 found that the elliptical bays are not present on the floodplains of modern rivers in the Carolina coastal plain, nor are they being formed by modern rivers or estuaries anywhere, so far as is known. The same conclusions on the basis of present knowledge must also be applied to the floodplains of the geologic past. It is clear that water destroys Carolina Bays. We switch our attention to New York, which was covered by the Laurentide ice sheet during the Wisconsin glaciation. This image shows the glacial striations on a large rock outcrop in Central Park. Glaciers grind rocks and carry rocky debris as they move. When the glacier melts, the rocky debris is deposited in rock piles called moraines. The advance and retreat of the Laurentide ice sheet in the New York region dropped a series of moraines that built Long Island and carved out the landscape of New York City. Long Island is formed largely of 4 spines of glacial moraines with a large sandy outwash plain towards its barrier islands in the Atlantic Ocean. The existence of any Carolina bays on Long Island would clearly indicate that the bays were emplaced after 18,000 years ago when the Laurentide ice sheet began retreating from the region. This image shows some Carolina bays in Long Island. If the bays had formed before the last glacial maximum, as suggested by the Atlantic shoreline terraces, the advance of the Laurentide ice sheet over New York would have erased them 26 to 20,000 years ago. The only logical conclusion is that the Carolina bays were made after the ice sheet retreated from Long Island. This makes it possible to consider that the Carolina bays are relatively recent structures that can be associated with the Younger Dryas extraterrestrial impact 12,900 years ago. So when were the Carolina bays emplaced? The best guess is that the Carolina bays were created by secondary impacts of glacier-ice boulders ejected by an extraterrestrial impact on the Laurentide ice sheet 12,900 years ago. The Platinum anomaly 12,900 years ago is indicative of an extraterrestrial impact, and it is associated with a mass extinction. The convergence point of the Nebraska rainwater basins and the Carolina bays was covered with ice during the late Wisconsin glaciation. Presence of bays on Long Island indicates that the bays originated after 18,000 years ago when the Laurentide ice sheet was retreating. Radiocarbon and optically stimulated luminescence dates are all more recent than 100,000 years, so the bays cannot be older than that. Storm surges, astronomical tides, and copious rain explain why the bays in the Princess Anne Terrace have eroded without the need for higher mean sea levels. The Earth's temperature record serves as a convenient backdrop for annotating all the conditions necessary for the creation of the Carolina bays. The chart also makes it possible to exclude the times when this event could not have happened. The glacier ice impact hypothesis is doing well. Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.